The notation I'll be forgiving on the quizzes, but I'll put a note on it. On the test, I won't be as forgiving. So by the time we take the test, I want you to really have this notation thought down. Hey, morning. So I like to say that this is the limit as x goes to 16 of like hashtag, right? So I'm gonna work on my replacement piece, yes? My replacement function. I know if I plug in 16 now, I get 0 over 0. So I'm going to just try and work on this, get the replacement function, and then plug in the 16, right? So upstairs, oh, I cheated there. Sorry, that's an X. So upstairs, nothing I can do. Downstairs, I can factor. And I get what? 16 minus x, yes? Is that right? Good, but I recognize, and I don't have to factor there, but it does make it easier. I need a conjugate, right? Oops. Come on, Robert. Get the brain working. Don't forget, I went to the Chili Peppers last night, so there was some. It's not, I can't say illegal anymore, but there was some activity around me. So I don't want to simplify, I don't want to distribute downstairs. I pick the conjugate of the numerator, so that's where I want to work, right? So what do I get here? I get a 16 minus x. Oh, look at that. Right away, I see that it's connecting correctly, right? So my 16, looks like my 16 minus x is going to cancel. You okay here with everything?
Okay, no, yeah, now.
You see it? Yeah, what was it? Was the conjugate?
I did it. So what I did was like I did x minus like I stated.
I gotcha. Yes, and remember, you wanna after you do something, you want to make sure it's correct, right? After you multiply by a conjugate, right? You want to, after you factor, distribute it back, make sure it's correct. And I see this mistake a lot. I'll get an answer like this. And what was the mistake? Yes, that should be in the denominator, right? So there's all of a sudden, there's my replacement function. And now I like going back to my limit. I can do it, go right back to here and say, oh, I know the replacement function now. And what do I do when I take a limit? I plug in my number, right? So 16 times 4 plus square root of 16. Notice once I plug in, I'm not writing the limit anymore, right? Is that making sense? Yep. And somebody help me. What is it, 4 plus 4? Nice. 1 over 1 over? Thank you. Thanks for not making me do that. Anything else you want me to do? Hey. You okay? Lana, yes? Do you have your mask? You can go down to public safety. Do you know where it is? Okay. Yes. Oh, please. Yes. Sheila, thank you. Yeah, it sucks wearing a mask. I guess some teachers are maybe lenient on it, but we're not supposed to be. They say I could take my mask off when I'm lecturing if I feel like it's safe, but I don't feel like that's fair. If you've got to wear it, I've got to wear it. Okay. We're going to get an update early October, and I'm hoping it's going to say optional masks, right? So, believe me, is anybody here? I mean, this is voluntary. I had COVID over the summer. It is absolute hell. Hell. It's the worst. It felt like there was glass in my throat. Oh, it was horrible. So you want to be safe. And this thing, it might not protect you, but it does a little bit, right? I live in DC. I can't stand the politics, but I'm going to trust the doctors who are put in charge, right? So eventually it could be some of you. You bio majors might be doctors, right? Anybody? bio major going to be a doctor? Okay, that's all right. I don't blame you. Ick. But I'll trust the CDC until. All right, we're ready to go then. Yes? No more problems for me to do? I like it. David, morning. Michael, morning. I think I said, Dealer, I think I said hello to everybody. Sebastian, yes. Sebastian, thank you. Nice. All right. We have one homework assignment due, correct? One problem due in 2.1, number 9, yes? Good. I want a second problem done that is on, we're going to create a secant tangent line on Desmos, okay? So we were working on it yesterday. I think we were doing derivatives, right? Yes? So I kind of want to take one of our functions. So let's say f of x equals square root of x. And we did this yesterday. We did the derivative of it. Does anybody remember it?
1/2.
Nice. Nice. 1/2 square roots of x, right? So we want to have all these memorized. Of course, we're going to put them on our formula sheet. You may use a formula sheet on every test and every quiz. It must be a single sheet of paper, right? And I want it out before we take the quiz. You're going to start taking the quiz. You go like, oh, can I grab this one page from my notes? No. Have your formula sheet, work on it. Create a masterpiece. By the time the first test comes around, it should be your whole course on there, right? Everything we've learned. Of course, things got to get pushed off, or writing has got to get smaller as we move further in the semester. By the time we get to chapter 5, right, it's going to be hard to have everything on there, David. Both sides. In fact, if you want, you can even use all the 4 edges. So yeah, so I personally, whenever I had a formula sheet, well, I didn't use them because I'm ADD, I get distracted, so I can't have extra pieces of paper. I'm weird. But I've had students have like 12 pages of notes, and you take photos of them or scan them, and you print as a PDF, and you can print 6 pages per side, right? And so you have now one piece of paper with 6 pages on the front, 6 pages on the back, right? And then you can still add in extra things. So little things like that are good to do. So this is our derivative. What is the derivative? It's what of the tangent line? The slope of the tangent line at any point. So now all of a sudden, like at 1, so here's my square root of x function, right? This is the point 1, 1. Now I can get the slope of that tangent line just with 1 point. So the slope is going to be f prime of 1, right? And that's the x value. Yes, you with me there? And so that's 1/2 square roots of 1. That's 1/2. The slope at that tangent line at 1, 1 is 1/2. I should be able to get the equation of the tangent line. You with me? With this formula, right? This is our new friend. We're getting a tattoo if we can't remember, right? This is our point slope form. My x value is 1. My x1 value is 1. My y1 value is 1. And my slope is 1/2, right? So y minus 1 equals 1/2 times x minus 1. I can go right to Desmos with this to make sure it's right before I bother manipulating. And then we would like to get that kind of that middle school version as quickly as we could. So we were doing, I'm adding 1 to both sides, yes? So I get y equals 1/2 x plus 1/2. Is this okay with everybody? So we're getting the tangent line, yes? And whenever I ask you to do this, of course, check it, right? Of course, check it. Is that Laura? Hey, morning. So Desmos, please make sure you're sitting at a computer that Desmos works for the quiz today. I'm pretty sure I've got the two figured out that don't work, right? The one here is the keyboard is not working. And Sebastian, you might be at the other one that's not working. Will you check it for me? Okay, so anywhere else is fine. Anywhere there's a chair, empty seat. Okay, except for that front one. Thank you. Sorry about that. I'd rather us have it all figured out now before we take the quiz, right? I'm very happy. It's 100% attendance again. 100% attendance, which is good. Awad, you came in? Yes? Yes, thank you. Nice. Very cool. Good. So let's see. Y equals f of x is square root of x, right? Oops. F of x equals square root of x, SQRT, right? We had the point 1, 1. And we had our tangent line y equals 1/2 x plus 1/2. And there it is. So I can really see that I've got it correct, right? It's nice. You're actually gonna. I think there's maybe one problem this semester that I can't easily check myself on Desmos. So every single problem you're gonna have this semester, including every single one on every test, you're gonna leave here knowing you have it right or wrong. The key is to not panic if you know you got something wrong, right? Especially on the quiz today. You do the quiz, you get the limit. You go check it on Desmos, it's not the same. Maybe you check it numerically and graphically on Desmos, right? And then it's still, and those two match, but yours doesn't. We're thinking you're the one that's got the issue, right? So you can look at your work. Maybe you can see the mistake, but most likely you'll just grab another piece of paper and start the problem over. Question, Melissa? Yes, yes. So show a check of a limit. Yeah. So we just had one we did this morning, right? Tell me that one again. It was it 4 minus 6 square root of 16? Yeah, 4 minus square root of x, right? All over 16x minus x squared. Yeah, thank you. So numerically, and we were doing this as x is going to 16, right? So numerically, I can hit that gearbox and hit the table, right? And then I need to get things really close to 16. Since I did it on my quiz already, I just check one side and see if it matches, right? So I'm going to go 15.9, 15.99, 15.999, and at that point, I should really know. And what answer did we actually get? Do you remember what we got? 1 over? Yes. So 1 divided by 128. And I'm seeing, is it matching up? Right? I could also graph it. So I know I'm going to x is 16, right? Right there. And you see how close, you see, as I'm doing the table, Desmos is plotting those points, right? You see I'm getting closer to the graph. But once I know the answer, I can just graph that. So I had 16 comma 1 divided by 128, and I want to see, does it hit my graph? And there it is, boom. Right? You with me? Calista, that help? So graphically, numerically, we're checking. All right. The second, yes, question. Only limits. Two questions, algebraic limits. It's not good. They're not going to be super. If you're practicing, the quizzes will always be easy. I'm just trying to, by giving like a one question quiz, and you knowing what's coming, I'm trying to alleviate some of the stress that comes with being assessed, taking an exam, right? Anybody panic sometimes in a test or go blank? Yeah, yeah. So you're going to have your formula sheet. You can ask me, okay? If you haven't figured it out already, I'm not going to say go away. It's a quiz. I'm going to say conjugate on with it or something. You know, I'm going to try and give you a little hint to get you to unblock. Okay. All right. I want you to create for me a dynamic secant line like we did before with that dynamic tangent line attached to it. And you're gonna sign into Desmos. It's free. Create a user account. It's free. And after you save something, it'll save to your account, and then you can share it with me. Okay, you send me a link. All right. So, watch what I mean. I'm going to use f of x again, a square root of x. And you can do this with me right now. I'm going to attach a point, a comma f of a. And the key here is that I want you to be able to do this with any function just by changing that first line in Desmos, okay? So take a look at what I got here. So there's my dynamic point, right? It's kind of silly to have a to be negative because it's square root, but I'm fine with that. If I put a as negative, there's no point on my curve, obviously, right? But again, I want to, if I adjust my domain here, when I change my function, I'd have to adjust again. So I'd rather just leave it as it is for now. I'm going to put in my dynamic tangent line. I know that my derivative is 1 over 2 square roots, right? So watch what I do. Y minus f of a equals 1 divided by 2 square roots of a. That's my derivative. All times x minus a. Is everybody comfortable there? Take a look at my now I have this, what I'll call a dynamic tangent line. So I can move a to 1, right? Just like before, and my tangent line moves. Now, what's the problem with this is the function, the thing I wrote here on line 4 is referring directly to the derivative of the function. I would like it to be changeable, right? So there's a couple of little things we can do. First of all, I'm going to graph my derivative to make sure, just to get a look at it. Okay, so there it is in green. And I want to use the feature in Desmos that will allow me to graph the derivative of the original function as well without doing the work, and that is f prime of x. I think this works. Oh, I forgot my square roots here. I was like, why does that not look the same? Square root of x, right? Yeah. So notice now in green, I've got my derivative that I did by hand. In purple, you see it? In purple, it's matching. The green one I did by hand, the purple one I did with Desmos. I have another option as well. I can use this feature, y equals d dx of f of x. And now it's in black. Do you see it? So there's my original one in green, right? There's my new one in purple with using the notation f prime. And then, of course, I can also use this other notation, d dx. d dx means derivative. Question. How do you do prime? It's just the quote, the single quote. Right underneath the double quote. Yeah. So, dynamic secant line with the tangent line, right? The secant line should go through A, f of A. Yes, you with me? The tangent line should be attached to A, f of A. What I want to be able to see, and so this is a student from the other class sent me one already. Let's see if I can open it. How do I open email? It would be helpful to be in school. There we go. Oh my God, what a pain! Do you do this yet? This double authentication thing? Such a pain. What is someone going to steal your grade, right? Yeah, again, if you're going to email me, you just email me directly, right? So don't go through Blackboard to email me. Don't go through WebAssign to email me. Jeffrey sent me this already. So once you send me something, it'll look like that, right? You send me something. So I'm going to open his. And so you can see as h goes to 0, my secant line becomes the tangent line. And what we started doing is limits. We said, hey, well, all right, get closer, and that's tell me what you think the tangent slope is going to be. But yeah, last class we started doing these derivatives. It tells me right away. It's the function that tells me the slope at any point, right? But we needed limits to be able to figure out how to get that function, right? What's nice about his sketch is now I can change my curve. I can change my function one place, and it gives me the same type of problem. Everything changes with the function. So look at my secant now. Sorry, right? Secant is going to be controlled by h, right? I want h to get smaller, and my secant becomes my tangent. Right? Is that clear? Everybody clear on what I want you to do? So you can send it to me earlier, but I want it Monday. I want you working on it. You have one question in the book, right? You have the dynamic sketch to send me, and it's okay if it's a little bit wrong. I'll just say, hey, your tangent line's not moving, or your tangent line's not connected to the right point, or something like that, right? But no, 9 is do 9 as you wish. All right, beautiful. Dynamic secant line, tangent line. Any function you want. Yep, any function you want. I'll go in and I'll change the function and make sure it still works with the new function, right? So you should do the same, right? Yep. Anybody a little overwhelmed with the semester so far? Me too. And so I'm not quite settled into, I don't have our homework posted right yet, and so you just got to give me a little time. I'll do the same for you, right? Usually the weekends when you can catch up, unless you're someone who works all weekend. Yeah, so that's tough, right? So you got to kind of chip away during the week. You just got to figure things out, figure out a schedule, get into a study group, have someone in class that you can call on and say, hey, what the hell is going on here? Right? Yeah, send it to me via email, right? My email is it's robert.kuhar at Montgomery College, right? The rest is the same as yours, right? No, one of them. Yeah. montgomerycollege.edu, right? All of this is the same for all of our emails, right? If it comes from a different email, like if you use your Gmail account or something, you just got to make sure you tell me who you are, right? Right? If I get an email from crazygirl@gmail.com, I don't know who the hell it is, right? And I'm sorry if I pick someone's email out accidentally, but. All right, so dynamic secant line, tangent line, yes? Beautiful. Last class we were doing derivatives. I want to do a couple more, okay? I forget what our last one was. Let me peek. Oh, we were doing limits there. Where's my derivative? Here's a derivative. Nice, here's a derivative. Good. Let me just start off with a new one. I'm going to say that y equals 1 over x. Does anybody know what y prime is? Anybody know what y prime is here? What is it? Say it again? Yes, the derivative. Almost. Negative 1 over x squared. So we have a shortcut here because I'm going to remember that this is x to what power? The negative 1 power, right? And so it's a power rule. If I have x to some power, I'm going to be trying to use the power rule, okay? So I get for y prime, I'm going to bring down the exponent and then take my current exponent and subtract 1 from it, right? Everybody with me here?
Yeah.
Yep. So I get negative 1 times x to the negative 2, but that negative exponent means reciprocal, so take it from the numerator and move it to the denominator, and there is my derivative. All these derivatives that we get, you can make a shortcut list. There's a nice list in your textbook in chapter 3, okay? There's also, if you have the physical book, the very back page should have all the formulas on it. Yes? Correct. Say it again? It should be. I haven't been down there, so I don't know. But I don't want you paying more than $55. Question? They don't have the book yet. They'll get it. We're supposed to get them any day. The library should have them too soon. No. On if you buy it electronically, we got a deal for $55. If you buy it at the bookstore, I think it's like $140. But it's for Calc 1 and Calc 2. Okay, question? Sheila.
So when you're, let's say I would use the shortcut in a test, you don't have to, like, can you just say I'm using the shortcut?
That's right, yeah. So you'll see on the test or on the quiz coming up next week, I'll say, find the derivative using a limit. Okay, and then for those of you that already know how to do these or already have these shortcuts memorized or you have them on your formula sheet, you know if you got it right or not right away. The key here is on Desmos when I'm doing these, right, if I'm doing this on Desmos, doesn't matter. Let me just open a new page. If I'm what is wrong with me today? I told you I went to the Chili Peppers concert. I'm not quite functioning well. So I had what? I figured out minus 1 over x squared, right? So f of x, or better yet, y equals 1 over x is my original function, correct? I don't really care about seeing it. I want to look at my derivative. I got y equals negative 1 divided by x squared, right? But I want to compare that to y equals, let's see if I can do it. I'll do it this way, d dx of y. Okay, it didn't work. I have to use, what's that?
Like, what does the
It means derivative.
oh,
Yep. So it didn't quite work for me, so I'm going to do it this way. Because now I can do my f of x here. I have to use the f of x notation, I guess. Nice, but look at it. Green and blue, right? They matched up, yes? Now that I'm using f of x notation, I can do it much easier. I can just do f prime, I think. Yes. So much easier than the ddx. But they mean the same thing, okay? Yes, everybody with me? So when you're doing those derivatives, you're going to be able to check them. There's another little subtlety of how to check derivatives as well, but I'll wait till we get to full-on chapter 3 before we do that. Good, let's do this limit now. Let's do this derivative using a limit, right? Reminder, and on your formula sheet, f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. Right? We're moving our secant closer. Right? We're moving those 2 points closer. H is going to 0, making those points go closer and closer to each other until we get the derivative. So here we go. F prime of x is the limit as h goes to 0 of 1 over x plus h minus 1 over x, all divided by h. You with me? Yep. So I see my original function, and what am I putting in first? X plus h, right? Then I'm subtracting the original function, right? y2 minus y1, all over h, which happens to be x2 minus x1, right? Rise over run kind of thing. It's amazing how instinctive, our instincts are really good with calculus. The algebra is where we will have problem, right? But the thought process is easy. I personally like to work on this function separate so I don't have to keep writing limit. So I'll just call it star. And I know star is my 1 over x plus h minus 1 over x all over h. And I can see I need an LCD. Who's got it?
x squared plus,
Yes, don't distribute. Just
oh, okay, x times x plus one.
there it is. Anybody confused on that? How to get that LCD? Really? No one's confused on that? Okay, thank you. So the idea here is I'm looking for interior denominator. H is a denominator, you agree? But that's the denominator of the whole fraction. I don't want to include that piece. So I'm kind of going, okay, there's a denominator of x plus h. There's a denominator of x. Here is the interior denominator of 1. I want to take all of those and multiply them together. So 1 times x times x plus h. And then why do I put it over itself? Because I'm only allowed to do nothing. The only thing I'm allowed to do is nothing, right? So, meaning I can multiply by 1, or I can add 0. Just so we could see it, I'll distribute through in black, and I'll keep the original in blue. Sorry, over x, right? Right? I mean, it took me, it takes some concentration to do that, but you can see I'm distributing into my numerators, right? Do you see that? Good. Now things cancel nicely, right? And I'm trying to stay organized here. I'm just trying to rewrite. Everybody's with me? So I've got upstairs now x minus parenthesis x plus h, trying to do as little as I can each step, baby steps, kind of. Right here. Yes. That's an H. Right from here. H. Yes, you're welcome. So I can now distribute upstairs. And it's like remember I think I said this to you, right? Pass the class, kill a tree, pass the class, right? Don't try and save paper. So my x's cancel here. And you're going like, well, oh, come on, why don't you just jump to the answer? You know it. Until I'm getting them right, I don't want to take shortcuts. Once I start getting things right and I'm comfortable, yes, take shortcuts. So now my h's cancel, and I get -1 over x times x plus h. Again, I don't want to distribute where I don't have to. I notice I had to in the numerator to get things to simplify. I don't want to distribute downstairs. It doesn't do anything for me. This is my replacement function. So I'm going to do the limit as h goes to 0 of star. And what do I get? X times x plus 0. Kind of a waste of time there, right? Because we know h goes to 0, so put in a 0. But look what I get. I get -1 over x times x. And there it is, -1 over x squared. There's my derivative. So on a quiz, I'll say, find me the derivative using a limit, right? On the test, I'll say that. If I don't say that, we're just going right with shortcuts. Okay? If I don't say that, like if I say, get me the tangent line at x is 1 for square root of x, I don't need you to go through that whole process to get the derivative. You've got it memorized already. How we doing? Yes, question. Sheila.
So what is the answer?
Yes, so this guy is giving me the slope of the tangent on 1 over x at any x value I want, except for 0, of course, right? Look at my function here, 1 over x. It doesn't exist at 0. And what's interesting is what happens when you plug 0 into the derivative. Oh, it's, yeah, 1 over x, yeah. What happens when I plug 0 into my derivative? Look at it. I get 1 over 0. So I can't do that either, right? So obviously, if there's a piece of the domain that doesn't exist for the function, it will also not exist for the derivative. How did I relate to this originally, this tangent guy? Do you remember me saying something? How did I relate to this tangent? Slope of the tangent line as what? The slope of my snowboard or skis or something, right? Remember me talking about this? And so, can I ski? Can I be skiing over 0 on the original mountain? No, it doesn't, right? It doesn't exist. And so certainly I cannot put that 0 into the, by the way, if I do ski down this, right? Eventually my skis are going to be, if I'm skiing down this hill, my skis are eventually going to be what? Vertical, right? Can you visualize it? Yeah. Of course, I'm screaming the whole way, right? But eventually my skis are going to be vertical, and when I put a 0 in here, I get it's infinite. That's vertical one, right? It's plus or minus infinity. I don't know which one, but definitely vertical. Nice. We'll do another? Yeah? I want you to notice that vertical and horizontal shifts of functions will show up in derivatives. A vertical shift will show up in a derivative. Horizontal shift will show up in a derivative. Verticals will not. Okay? So meaning, if I have f of x is square root of x, I already know that f prime of x is 1 over 2 square roots of x, right? But if I put a vertical shift on it, so I'll say g of x, different function, and I'll move it where? To the right or to the left? To the right. This one's to the right. So it's going to take my square root function and move it 2 to the right. Guess what the derivative is? Oh, g prime of x, sorry. Anybody have a guess? I don't care if you're wrong. Say it again? Nope. Goes to the right again. How much? By the same amount, exactly. So I get 1 over 2 square roots of x minus 2. So this is something that's going to be helpful for you if you see what I call the mother function. It sounds like I'm cursing, that's why I like to say it. Yeah, mother function or parent function. So the original function here, f of x, is what would be considered the parent function. And then, of course, I've got my new one shifted over by 2, and that's I'll say a daughter function, or, right, child. So the original meaning, as simple as it can get, right, square root of x. Now, why should this make sense? If I think about it, oops, sorry. That's still y, right? If I think about it in terms of me skiing, right? Why does it make sense that the derivative is a shift? Well, if I'm standing here on the hill, right? I got the slope that I got. But if I just move over to here, isn't it still the same slope? So it should make sense that if I move the hill, my skis aren't changing slope, right? If I move the hill up, still the same. If I move it over, still the same. All right, let's do this one with our limit. So we're going to use y equals square root of x minus 2. And we're going to get y prime, right? Or f prime of x. So square root of x plus h minus 2. Those parentheses aren't real needed. You'll get used to it. Everybody with me, though? Is everybody here? Okay? So again, I'm doing this one to get my derivative. It's the original function with x plus h put in for x. This is the original function. That's my difference. Quotient divided by h, right? Yep. So the original function evaluated instead of x as x plus h minus the original function, all divided by h. On your mark and set, go. Don't copy me, you do, right? Maybe you want to copy this first piece. I'm just doing asterisks. Those parentheses mean nothing. And then what am I going to do here at this point? Conjugate, nice. Over itself, right? We had a little special inside note that all of my non-H terms should go away. If they don't, I did something wrong. And it's just about organization. staying neat. So it's easy to get a little sloppy. Start writing sideways. We don't want to do anything like that. Kill the tree, pass the glass. How we doing? Anyone stuck anywhere? We get there? How do we check it on Desmos? Plot this function, plot the original F prime. Right? You say F of X is equal to this. Nice. We're done for today. Let's take the quiz. If you're done early with the quiz, just you're done. You leave. Yes. No. Okay. Just a stretch. No problem.